Hi, my name is Jester, and this is my lab for report. So the purpose of this lab was to understand and predict the motion of a mass swinging in an arc while also oscillating on a spring. And so, like for the kind of like the introduction, the principles we used, Newton's law of universal gravitation, which can be depicted right here. F1 is equal to F2, which is equal to the gravitational constant times both masses over r squared. And then Newton's second law um, with momentum and law of motion, where you have force equals mass times acceleration, which is equal to mass times the change in velocity over the change of time, which is equal to the change in momentum over change of time. And the velocity and like position update formula used here, and then also the energy principle, mainly with work is equal to the change in kinetic energy, and kinetic energy is equal to 1/2 mv squared, and the work can also be equal to the force times, or yeah, the magnitude of the force times the magnitude of the change in, or the displacement, and times cosine theta. And so the system was the mass and attached to the object, the spring, and the earth, and the surroundings were nothing. And so takeaways is if we assume there to be no external work done on the system, that would mean there's the change in energy is zero. And in reality, though, it would be hard to find everything that could do work on an object. So the change in energy would probably be zero in real life. So here are the assumptions we made. We ignored heat, ignored all forces except for gravity and spring, so like drag and things like that. Um, and also, it's just two-dimensional motion. So here is the video that we analyzed. Spring oscillating back and forth. And so here is the code. There's the initial conditions on the left and the calculations on the right. And I'll run my code here. Choose the file. See how it works. And all the graphs being made with X and Y positions and the energy over time. And so what do you call it? Here are the position graphs, X and Y position graphs with respect to time. And so the similarities, the periodic oscillations were observed in both experiments with similar frequencies. But what do you call it? Differences you can see on the left right here. The red line was very different. The amplitude was a lot shorter, and that could be due to error of some external work happening on the object, or just error of like the way I put or tracked it in the tracker. And then what do you call it? For the question, is the energy principle satisfied? Yes, it is, because as you can see here on this graph, that orange line is the change in energy, like I said before. No, yes, it is, because there's no outside forces done on doing work on the system, so change in energy should be zero, and the orange line is constantly at zero. And so for the end, the possible error could be rounding off errors, and like ignoring outside work. Thank you.